Hello friends, I am Naren and back with another video. This is very interesting video because today I'm going to talk about my real experience about a DevOps technical interview process. Recently I give an interview for a DevOps technical uh, interview, and this is like a company has asked me to design a CI/CD pipeline for their DevOps processes. So I found this is very interesting and I would like to share with you all as a DevOps engineer, so you can get an idea like how a company asking a technical interview questions to a DevOps. So let's get started. And the diagram that you are see on the thumbnail, this is the diagram we have to build today in this video. So let's get started to understand how the whole requirement is working and how we are building the CI/CD DevOps flow to fulfill this requirement. First, we will gonna take understand the requirement from the company. This is very simple requirement but yet complicated. So let's understand the requirement, what project a company has requested to build in the technical scenario. This is the home base assignment that a company give assignment to me, and then I have to build this assignment in one day. So let's understand the requirement. You are working for a company that wants to deploy a containerized application on Amazon EC2, and launch type is EC2, using Terraform infrastructure, a Git hosted pipeline in YAML, and environment variable stored in GitHub Secret. The system include. So company saying that company want an application that deployed in a containerized application in Amazon ECS. ECS is nothing but Elastic Container Services, and the EC has two types of launching mechanism. One is EC2, another is Fargate. If you choose the Fargate, then everything handled by AWS. But if you choose EC2, you have to register your EC2 inside the ECS. We will see later in the demo how you can do that. Okay, now here are the few system in the system should include the following. We have to create ECS for hosting our application, and then we have to EC2 instance as a worker node of ECS, so ECS can run the container inside your EC2 after you register it on ECS. RDS database as a backend. Of course, like if your application require a database configuration, you can define your database, but here company saying that their database is RDS, that MariaDB, and a S3 bucket for storing a static file. This is also the requirement, and EFS for shared storage, and CloudFront from the CDN and caching. This is the company application. Okay, this is the company system requirement. They mention this kind of application is they are working on it. Okay, but we suppose not to design the complete system. They have asked us what exactly we have to do as a task. So they provide a Terraform file and they are asking fix and complete the Terraform file. Probably they made some mistake on the Terraform file and they want you to correct the Terraform file. Okay, that's fair enough. Write GitHub Action CI/CD pipeline, meaning you have to design a CI/CD pipeline using a GitHub Actions. Of course, GitHub Action is more like a YAML file, so you have to create the YAML file with the flow that they describe below. Explain how environment variable from GitHub Secret are used in the deployment. This is again is more like a explanation question where you can use the README file where you can explain, or you can directly using this secret GitHub Secret directly in your CI/CD pipeline. But better to explain, since they asked to explain, so better to explain in the README file. Ensure the deployment work in AWS ECS with EC2 launch type. And then the fourth task is we have to make sure whatever script you design, that script should work and launch the EC2 with launch EC2 launch type, right? Now fix the Terraform code. I am providing with you a Terraform file at main.tf that has an error. You must identify and fix the issue. Okay. And then second requirement, that we have to write a GitHub action in the development.yaml file. In that we have to push the Docker image to ECR. ECR in AWS is nothing but a more like your private Docker registry, similar to the Docker Hub, but Docker Hub is more like a public registry, but they wanted you to use AWS ECR, Elastic Container Registry. This is more like a private registry. Apply Terraform configuration in the AWS, that's fine. Use the GitHub secret for the sensitive information. Sensitive information is more like your AWS account key, that means like access key and the secret key, that kind of the stuffs you can add in your account, and not in your account, yeah, in your GitHub repository you have to add this information. Okay, and then could you clarify how to use environment variable from GitHub secret, and how, again, the step 3 is easy, that you just need to explain. So let's understand the whole requirement. In this requirement, the company asks create one ECS. Okay, and the ECS, we know it's a container services, so ECS does not contain any deployment, but it contains a blueprint of the deployment, meaning you have to create one ECS, and then inside the ECS you can create one service, and you can create the task definition. Task definition is must. Okay, and then you have to create one EC2 instance and make sure your EC2 instance registered in the ECS. Then only ECS will assign the task that you define to EC2. This is one task, and we also need to create the GitHub secret, and then we have to create a GitHub action CI/CD pipeline where we are building the Docker image. Okay, so now let's understand the flow. Okay, so we can go to our PPT to understand the flow. So initially, just assume that you have one repository and your dev want to commit something on the repository, and since the requirement is that we have to get the secret from the GitHub secret, so inside the repository you have to create few secrets, so you can later in your CI/CD pipeline you can fetch the secret in order to configure the AWS. Okay, now assume that the dev commit something on the Git. When the dev commit finish and it commit on the master branch, it will be trigger as GitHub action. Okay, once GitHub action will trigger, of course GitHub action have multiple action inside it, and then once all the actions finish, we will deploy the application inside the EC2 in a container way, and then the user can access the application. This is a basic requirement for the company. Now let's check what actions the GitHub action perform. So in the GitHub, first, we will fetch the secret information inside the environment variable. Once environment variable is created, we are building our Docker file. We will build a Docker image from our Docker file, and once built successfully, we are pushing the Docker image to ECR. Now the ECR, the company does not ask us like how we can create ECR, so I suggest you can create the ECR out of this flow. Now you may have a question that, Naren, okay, we can create out of this flow, but why not with this flow? That's a great question. ECR is something like a common for every organization. Like for individual project, you are not creating a container registry. You are pushing the Docker image makes sense, but for the company level you might have one common ECR that's shared between the teams, and each team push their Docker image to the ECR. So that's why I think it's a great way that putting ECR outside before you are triggering the CI/CD pipeline. So creating an ECR is not a big deal, and it will be not charged by AWS until and unless you are you are reaching the limit of your Docker push limit that AWS set. Okay, once we push the Docker image to ECR, then Terraform will create ECS, Elastic Computer Services. It's like ECS is more like I would say a light version of Kubernetes, right? So you can create one ECS, and also we have to create an EC2 S3 bucket. I put it inside, but it's a great way to, if we are putting the S3 bucket outside, because we are going to store the Terraform TF state file in this S3 bucket. But since we are running a CI/CD pipeline, so it's always be better that we are if you are working as a team, you go for the S3 bucket to store your TF file. But if you are working as a single, I suggest you can prefer the local one. Same like me, that I prefer the local one, but you can also, you know, putting your Terraform TF state file on the S3 bucket. Okay, now ECS requirement, we will create a dedicated VPC for deploying the ECS and EC2 instance in that VPC. Now all the instance, okay, after everything is done, we will, you know, deploy our application to EC2. And how the deployment is work: ECS, inside the ECS we have a task definition, more like a task blueprint, where the task is nothing but we are specifying that how your container parameter that can help ECS to launch your container. So we are define a container definition, more like a container definition, where you can specify which image you want to deploy and all this thing. So we probably, you know, deploying image that we have a build and put it into ECR. So ECS refer the image from the ECR and run the container according to the blueprint of the task that we have defined in the ECS. So this is the overall flow that we are going to create. So now let's move to our console in order to, okay, now this is our Visual Studio, and this is our application that we want to deploy using ECS, and the launch type is EC2. Okay, so this application we are going to deploy. So now let's go to the console area, see clear. Now we have this project we already opened on the Visual Studio. So in this project we have two things. Okay, we have workflow, actually three things. We have a workflow defined in the .github folder. Inside the workflow we have a development.yaml. This development YAML you have to create as a requirement. We will discuss in detail what this YAML is containing and how it's working. Then we have a CI/CD. In the CI/CD we have a subfolder called infrastructure as code, where we have a main.tf and variable.tf. Okay, and create ECR, that container registry. We have the script for creating container registry, and that we will use to create our container registry. Okay, great. And similar way we can also delete the container registry. Now let's check the third part is the Docker file. When you are working on the GitHub workflow, you design the workflow here, meaning you are building your Docker image inside the workflow, but your Docker file should be in the root folder. Okay, so if you have a different path, then you have to specify -f option in order to get the Docker file path. Okay, that's just a simple information. Sometimes people are, you know, putting the Docker file inside the workflow, but that completely wrong. so it will be not detect the Docker file. Okay, so now let's understand our deployment.yaml. But before understand this deployment.yaml, we have to make sure this secret parameter is exist in our GitHub secret or not. So let's go to the browser, and we have here a repository called manage contact demo. This is a simple application where you can enter contact information and it will be stored in the PostgreSQL database. I am using the PostgreSQL database here, although company asking the MariaDB, but it's like a company requirement. But you will understand uh, the complete picture. Database doesn't really matter you use the MariaDB or the Postgres. Since my application code, I already have this application built many years ago, so this application is using the Postgres. So we want to keep the same database and using the existing application. So we will going to create the Postgres SQL database. Okay, now let's move to the GitHub secret part. So right now we have a repository. See, GitHub secret you cannot create without a repository. So the secrets you are creating, that secrets related to this repository, whatever CI/CD you are running inside this repository, the secret belongs to this. So go to the setting. In the setting, you have a secret and variables. Go action inside this, and inside the action we have a repository secret. So you can click on this new repository secret to adding a new secret value. So here I already added 3. It's like my AWS access key ID and AWS secret access key ID. Okay, this is the simple way you can create our GitHub secret here. So that is for the GitHub secret. Now let's jump to the code, and when you are accessing the secret, so you have to put like a dollar double curly and the secrets dot your key name, then it will be assign a value to this variable, and then similar way your key name like AWS secret access key, and it will be assigned the value to this environment variable. And apart from this, we also create the environment variable for our Docker AMI. So we are planning to deploy this manage contact app as our Docker image, and we will choose image tag is the latest one. That's fine. Now let's define the job. Okay, and we are building a job, and we want to run this job on Ubuntu latest version. So when you are working on the GitHub, okay, GitHub has a pre-configured runner. Okay, so we are not doing any effort for creating a Ubuntu latest container. The GitHub will help us to build this container for us. So meaning in your account, if you have a GitHub account, your account will configure by default one runner, and we are using that default runner in order to launch a new container from the Ubuntu AMI. And the version of Ubuntu OS is the latest, whatever the latest version. We don't know whether it is 24.04, but whatever the latest version, we should deploy. Now after container deploy, and we are launching few steps. First step is checkout action. This is very handy when you are using a GitHub actions. GitHub action already provides some common functionality that is stored in GitHub marketplace. So we are using the checkout process from the GitHub market process. So here we are saying that of course you can do manually, like adding the command GitHub git clone and then your repository name. This will also work, but better you can use the public actions that can help you to customize your code, and it looks good. Okay, after the checkout, we have to make sure Sometimes some operating system already install AWS CLI, right? So we want to check and install AWS CLI on Linux machine if it is not exist. So here I am checking whether the AWS CLI is installed or not. If it is not installed, then we will going to install the AWS CLI. Otherwise, we will printing the message with the version of AWS CLI, and then we are running this command just to make sure that it's working fine. After that, we have to configure the AWS credential for Terraform, right? Like when we are running Terraform init, so Terraform should communicate with your AWS account. So what we are doing is we already setting the AWS access keys here on the environment variables. So we are simply creating the .aws folder. Inside this we will create two files, credential and config. In the credential we will put the credential, and in the config we will put the region information, and the output is JSON. Generally there are two format, okay, JSON and the plain text. Okay, now once the AWS configure, it is really become important to make sure that your configuration is working fine. See, whenever you are writing a GitHub action, make sure whatever action you are configure and just verify those action that is configured well or not. If it is not configured correctly, then your pipeline continuously failed for some unknown reason, and then you need more time to investigate. To save the time, it's always better to validate your caller identity. Now, once the AWS configured, we can run this command. This command will success if you configure AWS successfully, otherwise it will be throw the error. Okay, so this was the extra step that we have to proactively doing before we are performing actual task. Now here are the things that now we have to build, tag and push the Docker image to ECR. So we are building the Docker image by running docker build command, and then we are getting the account ID. Since your ECR require this account, and ECR URL is looks like this. So you have account ID and then some this string, and then you have a region where, and then AWS.com. So here we get the account ID, and then now we have a repository URL. We will print the repository URL to make sure that we use the correct repository URL. Now we can tag our image with this repository URL, and then after tagging, it's time to push your Docker image to ECR. But before you are pushing, you have to make sure that you are logging to the Docker, right? You have Docker installed, but still Docker by default configure with the Docker Hub. Okay, so when you are pushing anything, it will goes to the Docker Hub public repository, right? So but we want to use our private ECR from AWS, so we have to logging to AWS first from Docker from the repository URL. So here is the command you can perform: AWS ECR get logging password, and region is this will return a password, and then you can use the Docker logging username AWS. This is the by default username, you can use it, and password whatever the command written here, we will use this password as a password, and here is our repository URL. Once logging gets success, you are allowed to push your Docker image to AWS ECR. So here is the Docker push and the repository URL, and this ECR you already built this tag image, right? So we are going to, because we have put the repository URL, so this is your repository URL. In this URL you have push this image, so we are saying push this image. Okay, now we will also set the new environment variable with this Docker with our image URL, right? So this is another way you can, if you if you not specify the environment variable on top, then you can creating the environment variable and add it to the GitHub environment variable. So this is the way you can create environment variable inside the steps, so that your next steps can use this environment variable. Now, okay, so deployment EC2R is done. Now we have to build our Terraform script. Of course, we will discuss Terraform script after this pipeline finish, and then I will guide you what we have added in the Terraform script, right? So before we init before we run init, plan and apply command from the Terraform, we have to install the Terraform, because by default in your Ubuntu container Terraform is not installed. So it's your responsibility to install the Terraform. We have installed the Terraform by running this command, and then we will check the version of the Terraform. If everything looks great, good, fine, then Terraform will install and it return the Terraform version. After returning the Terraform version, so we are supposed to generate a terraform.tf var. This is nothing but we are define a value to our variable, that variables that we are used in Terraform main.tf file. So Terraform tf var is the default file name. So if you are not specified any value to the Terraform variables, Terraform will look these files, and if this file is exist, then Terraform use the variable value from this file. So we are creating a file terraform.tf var in this location CICD IAS. This is the same location where we have the Terraform scripts, and we also putting the image name, Postgres user, Postgres password, and the DB name. Since my container require, I'm using a Postgres database, and my container require these two information. And then I'm displaying content of these files to make sure that all the value that I want to add in this file is added successfully. After that, I can run the terraform init command, but here you can see I set the working directory, because we are in the deployment, we are in the GitHub workflow, and we have to change the directory. So in order to change the directory in the GitHub, you have add this in the working directory and then give the path of the directory. Here we give our terraform script directory where we store the terraform script. Now we run the terraform init, and the similar way we run the terraform plan, and then we will, then plan goes well, then we will run the terraform apply auto approve, and then waiting for 5 minutes. Since we are just preparing a demo, right? So whatever resource you allocated or whatever resource you launch or provisioning from using terraform, we have to destroy them, otherwise it will be cost money. To avoid such case, after running the application 5 minutes, we can destroy all our resource that we have created. 5 minutes is more than enough for us to checking whether the application deployed or not, and then our pipeline will end. Of course, you can add the further steps where you can notify your, when you are working on the real when you are working in the company, you have to notify your team that deployment is done. And when you are handling such kind of the task, when you are in company, you suppose not destroy after 5 minutes. Suppose, let's say you are deploying application for QA and for the developer team, so you have to notify them that okay, deployment has been done successfully, and it will be alive for maybe, let's say, 8 hours, for 10 hours, 48 hours, whatever, according to your company policies. Okay, or maybe you can keep running forever until a new application has been deployed. Okay, so this is the way, but the best way is make sure you can deploy your application and run it for working hour, and in the night you can destroy the application, and in the morning when you come into the office, or developer or QA come to the office, you can automatically deploy this application again before they start their work, right? So this is our GitHub pipeline. Now let's move to the our Terraform script. In this script we have 4 files. Create ECR. If you did not have any existing ECR, create ECR. I give a repo name here, and this command will help us to create this repository in the ECR, right? And then after you finish this project, you can also run the delete ECR project, and it will be delete the ECR. Now let's take a look on the main file, and we have few variables here that I am not define any default value, but these variables get the value from the terraform.tf var that we have generated in our GitHub. It will be generated here. Now let's take a look of main.tf file. Main.tf file is little slightly bigger, and here we are providing a required provider, and then we setting the AWS provider. Now this steps is not really required because this is the random ID. We are not creating a bucket here, right? So if you are creating a bucket, to make the your bucket name unique, we have to add the append the random ID, so it will your bucket will become unique, and it will not throw the error that bucket name is already exist. Okay, and then we are creating one VPC. Under this VPC we are handling everything. Okay, so we have a resource that add the VPC. Inside the VPC, as you are not familiar with the VPC, I strongly recommend you can watch my Terraform playlist on the YouTube. It's already live, and there I can discuss what are the things required to set up your new VPC. So here you can run this resource AWS VPC, and this become my CIDR block. And I also create internet gateways to access the internet from the container from the machine. And then we have a AWS subnet. We define a public subnet. Of course, public subnet require the a CIDR range that you have to specify, and you must enable the public IP on your public subnet, right? So we have the map public IP on launch. Route table, we create one route table, and then public internet. So we associated the route table to public internet and also associate the internet gateway. Then we also associate our public subnet to the route table association, and then we will give the public subnet ID here, and then also give the route table ID. We also configure the security group. See, I open 2 port here, 2022. 2022 is really not necessary, but in case if you planning to connect to your EC2 instance, you need this 22 port for SSH, right? So if you not planning to connect your machine, you can simply disable this code. You do not need this code, right? And ingress is required because my container is start on port 3000, and I also have a Postgres. But if you want to access your Postgres database outside the machine, then you have to expose this port, otherwise you can disable this port as well. And egress, anyone can communicate to this machine. Now, so basic part has been done successfully. We have done the basic VPC part. Now let's say when you are working on ECS require 2 permission. Amazon EC2 container service for EC2 role and container registry read only. So for that we are creating one IAM role. I give the IAM instance profile here, and I will give the IAM role is ECS instance role, and this is the policy that we are going to attach with this role. Apart from that, we are also attaching two required permission, and this is the way you can attach the required permission. Okay. And finally, once everything is done, you can assign your role to the IAM profile EC2 instance profile. Okay, so you can assign your newly created IAM role to your ECS instance profile, meaning when you are creating the EC2 instance, you have to assign this role profile to your instance in order to get the desired permission or required permission. Now, key pair is really an optional things if you want to connect to the machine, since we have disabled the port 2022, so we have to disable the key pair as well. We have to disable the key pair as well. This is not really required. Now here is the AMI. Now it's time to create the AWS instance. So we are creating one EC2 instance. To creating EC2 instance, we need a AMI ID. So instead of define the AMI ID directly here, I prefer to filter the public AMI. And now this is the important part. Like when you are filter the public AMI, make sure you are filter the Amazon AMI ECS related AMI. See why ECS related AMI? When you are register your EC2 instance to ECS, EC2 instance should set up the ECS agent inside it. If you are using a plain Ubuntu AMI, then you have to install Docker and set up the ECS agent by yourself. But if you use the public AMI with already configure the ECS, then you should avoid these two tasks, and it will be very easy when you are avoiding these two tasks, because otherwise you have to write a further script where you are installing the Docker and you are installing the ECS agents. Okay, so we are trying to avoid that, so that's why I am filtering Amazon AMI ECS HVM, and in the middle I don't care whatever it is, and then at the end it should be end with this, and it will be return the AMI ID, and that AMI ID I will assign to here. Instance type is G2 micro. This is the basic instance on the AWS you can create. Assign the subnet ID, security group, key pair, since we disable the key pair part, so you can disable it, and we are assigning the instance profile. Instance profile, we have already created a new role that is attached to few permission. We attach few permission to that role, and we are assigning an instance profile. Great. Now I also write down, like if you are using a base AMI, base Ubuntu AMI, then you have two options. Either you can define your Docker installation and ECS agent package installation code in the user data, or you can use the provisioner and executing all the steps inside the EC2 instance. If you are not familiar with the provisioner, I have created a dedicated video in my Terraform playlist. I strongly recommend you can watch the provisioner video to understand how the provisional things work. And then after you define your script, installation script, you can connect to the instance, of course, with the key, and then it will be connect first and then execute your installation script. Now S3 bucket, we do not need it, so we can disable, since we are storing our Terraform TF state file locally, so we are not gonna creating the S3 bucket. Now here is the AWS ECS cluster. We give the name default. This is the default name when you are creating the cluster. Now inside the cluster we are going to add a resource called ECS service. In the service we will tell what is the launch type and the task definition. This task definition is defined below, we will discuss in a minute, and we will give the service name. Now here this is the very important task, and this is the task that we are deployed to our EC2 instance. This is nothing but a blueprint of your container. So we give the task name, family, and then required capabilities is EC2, since it's our requirement that we are going to working on the EC2. And then we have a network mode. Network mode is bridge. This is more like will help us to creating the both the container in the same network. Of course we are running the two container, one for the Postgres, another for your application itself. And then CPU, the global CPU and memory for all your container. And inside the container definition, we are defining our application, that I give my application container is MC app, and I'm getting the image from the parameter, and this parameter get initialized from our CI/CD Git flow. And then I'm getting the image ID, and then memory and CPU. Since I have two container, so I will divide CPU and memory equally to both my container. And port mapping, container port 3000, host port is 3000, because my application run on the 3000 port. But if you want to run them a port 8080, then you can change the host port 80 and keep the container port 30. And depends on, of course, my application container depend on the database. Once the database container become healthy, I want to start deploying my application container. And this link is important here. See, when we are deploying two container in the same machine, of course the container, assign a dedicated IP for each container, but getting the IP is little bit tricky here. So I want to access my container from the container name only. Okay, that's why this link you have to provide. Although this link is over this link is obsoleted. I believe the link part is obsoleted in the Docker latest version, but better you can define it here. So this will make sure that you can communicate between the container using the container name. And this environment is required for me to set up the connection to the database. That's why we have a DB host, Postgres user, Postgres password, and Postgres DB. All this value comes from the variables, and the variable get initialized from the deployment.yaml from the terraform.tf war file. And then for the Postgres database, I am using this name MCDB and using a public Docker image that will be fetched from the Docker hub. And similar like port mapping 5432 and environment variable is this. And here I'm checking the health check of my container. So every 30-second interval I am running this command to make sure the container is healthy or not. So that's it for this project. Pretty much we have done each and everything which is required to deploy our application. So now let's commit something. Okay, because as in the beginning of the video we have saw the workflow, right? So at the developer, let's say we have comment some files, right? We have comment some statements in the main.tf file. So let's say git status, we have few change, git commit. Before the commit we have to add, let's say I want to add the committed area in the my main.tf, and then I will say git add. And you can also my ape.png that we have seen beginning of the video, and git commit, and let's say disable creating s3 bucket. Okay, and that's it. And then we are going to push it, git push origin master. Now if you look at deployment, when somebody push a push event on the master, this GitHub action will trigger. So now let's try to push. We are pushing to the master. Master has been updated. Now let's, after successfully push, we can go to the action. Now you can see disable creating S3 bucket commit is running something. Now let's check what is running. Is now we have inside this, we have a build steps. In the build we have so many steps that we are pushing, building and pushing the image. And by the way, I already created the ECR URL in my AWS account, so it will be pushing the image to that ECR URL. If we want to see ECR, then you can see Elastic Container Registry, and you can go here, then you will see a manage contact app ECR URL. This is my ECR, and then we have to go ECS, since soon or very soon it will be deploy the ECS as well. And we also have to go EC2. It will also create the EC2 from the Terraform. But before we see, okay, so now the resource Terraform apply command is running, and we are creating the resource. So 15 resource is going to be added in this case, and we are resources added successfully. You can see resource added 15, and then we are waiting for 5 minutes, and this waiting is just to show you what exactly is happening. So if you go to EC2 instance, you probably see one instance is initializing and it's running. If you go to EC cluster, you can see a default cluster that we are creating, and then inside the cluster we have one MC services that we have created. In the task, we supposed to have one task that is pending actually, and this task is nothing but the task that you have created to container. Right now, check a look about our EC2 instances running, and in the IAM we also create an IAM role. So you can go here on IAM role, and once you go here, you can go inside the role, and you probably see your role EC instance role. And if you go inside this role, you will see two permission that we have attached to this role. That's great. Now EC2 instance is initializing. Now we are here on our cluster. Go to default. Now here so far 0 EC2 is registered, right? So meaning in your ECS you did not register any EC2 just because EC2 instance is initializing. Once this ready and accepting the code, then it will be registered to our ECS. So let's keep refreshing it. It won't take, it will just take 1 and 2 minutes to get ready. And let's refresh here to see whether it's okay. Now you can see one in EC2 instance is registered, meaning your EC2 instance has been run ECS agent inside it, and after agent is running, it will register your EC2 instance to this default cluster of your ECS. Once this is done, then you can probably go to the public URL, copy this URL, and you can paste it here in order to access the application. Now let's say port 3000. Let's see whether the application has been deployed successfully. Now let's check the database connectivity. If everything goes well, then it will be stored this information in the database. So let's say this is my mobile number and @n.com. This is my email address, and the email address added successfully. Another one h@h.com, and we will add this second one, and let's delete this one. Okay, so both the container has been configured successfully. Now let's say we can you can see the checks, all the check has been passed. Now go inside this default and we have a task, we have the task definition. If you go scroll down, then you can see both the container is running. And if you go here in the MC app, you can see network binding, you can see the URL that you supposed to access here. So this that's all for the technical interview assignment for the company that asked to me, and this is how this assignment is working. If you want to see a video like this, I recommend you like my channel, like my video, subscribe my channel, and write your request in the comment below. Thank you for watching this video. Have a great day and see you in the next video. Thank you very much.